Every carbohydrate conforms to that formula, including mini glucose condensing. So that's what you have. Now, there are other simple sugars apart from glucose. Who can tell me 3 more simple sugars, simple monosaccharides? We have what? Fructose. What? Galactose and mannose. Please take note. There are 4 monosaccharides. There are 3 apart from glucose. Mannose is on the board. These are monosaccharide. Mannose, glucose, galactose, and what? Fructose. Among the 4 examples, one is a ketone sugar. Which one is a ketone sugar? Fructose. The functional group of fructose is CO. It's an alkanone. Why the rest is what? CHO, and what? CHO. But take note, all these sugars you see here, they all have the same molecular formula, which is what? C6H12O6. What it means that the 4 sugars are what? Isomers. They are what? Isomers. They are isomeric sugar. Sugar with the same molecular what? Formula. The only thing that distinguishes fructose from glucose is dash. The thing that distinguishes fructose and glucose is dash. The functional group. That is the only thing that distinguishes functional group. Glucose is alkana. Fructose is what? Alkanone. Period. That is the only thing that differs there. But so many things brought the 2 sugars together. So many things are common between the 2 sugars, which is what? Both sugars have the same molecular what? Formula. Or both sugars are isomers. The sugars are isomers. Isomeric sugar. There are 3 examples of dimeric. Dimeric is when you have 2 monosaccharides coming together. What are the 2 or 3 dimeric sugars or disaccharides? Okay, tell me. What are they? 1 is what? Maltose. 2 is what? Sucrose. Sucrose is also called what? Invert. I think I told you before. Invert sugar. The last but not the least is what? Lactose. They are disaccharides. If I look at how they are formed, maltose is glucose plus what? Glucose. Is equals to what? Maltose. In fact, the second one is what? Glucose again plus what? Fructose. That one gives me what? Sucrose. Another one again is what? Glucose plus what? Galactose. And that one is what? Lactose. These are disaccharides. And all these disaccharides have the same molecular formula, which is what? C12H22O11. They're also isomeric, just like simple sugar. Okay. Okay, now, it will interest you to know that glucose, fructose, galactose, mannose, maltose, lactose are reducing sugar. But sucrose just what odds sugar out. Sucrose is a non-reducing sugar. Sucrose is the only non-what? Reducing sugar. All sugars, both simple sugar like monosaccharides and disaccharides are what? Reducing sugar. Except what? Sucrose. I will tell you why. Ordinarily, sugar that are reducing are sugar that have this functional group. What is this functional group called? acanal. This acanal is totally absent in fructose. So fructose before now, to some, even some teachers will tell you that fructose is a non-reducing sugar. It's not their fault. Because sugar that have the tendency to reduce ferritin, copper, too. Because both ferritin and the Benedict are all copper inside. Are you with me now? So sugars that reduce by ferritin, they are being oxidized by ferritin, are sugar with what? CHO. For the active ingredient in that reducing property is what? Hydrogen. I want to ask you a question. What is reduction in terms of hydrogen? It is what? Gain of hydrogen. It is the hydrogen. But you don't see that in fructose. Look at the structure of fructose. Look at fructose. Fructose is this. Don't worry, nobody is going to ask you to draw sugar like this. I pray they will not ask you this kind of sugar. Okay, what if they ask you, tell them 1, 2, 3, 4, 5, 6. This is fructose. What is the other name of fructose? Okay, for every division of fructose, if you like it, fructose is propanone. Come propanone. Propanone 1, 2, 3. The functional group is CO. Then CO. This is fructose. If I want to name this fructose, I'll name it as what? 1, 3, 4, 5, 6 pentahydroxyl hexanone. Or hexanone. That's the chemical name for fructose. It's the same molecular formula. If you know C6, H12, the Queba, O6, one okay. That's the same sugar. Check here. The fructose is totally a non-reducing sugar. Many annual toasted. But if you reduce as a reducing sugar, is simply because the fructose can easily isomerize to glucose. Okay, maybe isomerize. Isomer. The sugar can easily what? Isomerize or epimerize. How would the same molecular formula? So how do you change? How do we find about motor rotation or change? So the reason why it is reducing, now listen to me. They don't think they will ask you, it is advanced. The reducing property of fructose to ferritin is because it can easily isomerize. Please, isomerize means change to glucose. It can easily change to glucose. If you enter medicine, there's what called biochemistry 102, general biochemistry. They would tell you in glycolysis that glucose 6-phosphate is changed to fructose, is isomerized to fructose 6-phosphates. The fructose 6-phosphate undergoes another phosphorylation to fructose 1,6-diphosphate. If we have glucose and fructose, they can easily what? Isomerize. That is the reason why fructose is reducing what? Sugar. But now that you have glucose and fructose, the sugar is now called invert. Invert meaning that the sugar now, the two molecules have different functional group. They can't what? They can't reduce by ferritin. Hey, Kwichirigo, how do you go very rigid to ferritin solution? But let me tell you, I have an information this morning that they may want to confuse you. In this case, GCE, they brought that idea last GCE. They now use an acid on sucrose, and then they now say add ferritin. If you add ACl to sucrose, add ferritin and warm, the sucrose will give a positive test for simple sugar. So it means that the sucrose can also be reducing only after what? Hydrolysis. So they ask you, a sugar upon hydrolysis gives reducing property or reducing ability to ferment. The answer is what? Sucrose. Among all the sugars you know, it's only sucrose that on hydrolysis can give positive test. Others can do that test, can give that positive test without what? Hydrolysis. Sucrose need to be hydrolysis. Hydrolysis of fructose will give you what? Hydrolysis of sucrose will give you what? Glucose and fructose. Once the two sugars split into two, then the glucose of that will reduce failing. So the sugar that on hydrolysis can give positive test is what? Sucrose. But if there is no hydrolysis, please take note, there is no reducing property. So automatically, sucrose is a non-reducing sugar, but can show reducing property upon what? Hydrolysis. What is hydrolysis? What is hydrolysis? Hydrolysis is just you split a complex compound. A complex compound splits into simpler compound using what? A molecule of what? Water. That is what it is. It is a reverse of condensation. I could make condensation now. Nobody is not careful. I really say that is what it is. Now, one common reaction that simple sugars together with disaccharides undergo is simple. The one reaction they all undergo is that when they are heated, they blacken. When you heat sucrose, sucrose is the sugar you use this morning to drink tea. If you have taken tea, it's sucrose. It is from sugar cane. The natural source of sucrose is your cane sugar, sugar cane, or sucrose beer. If any carbohydrate that you heat, we must blacken. That black it turns is called what? Char. It's called what? Char. Char means that the sugar has darkened. If you heat it's China secretary. Now the boy gas it in 1 cube of sugar there. See heat that sugar. The sugar will what? With char. Ndo ko kosi na hanele manango na Holy Ghost. Ne yane me hane sugar yeshi. Ha share with milli o ka say share. Sugar brown no. Yane let's get as manango with brown sugar. Because the first thing that happened, the sugar will brown before it darken. That darkening is called what? Charring. So carbohydrates are known. Any sugar, any organic compound upon heating, blacken is carbohydrates. Once you get there, come. Oh, yes. Okay. The guy who go on the top. Okay, so sorry. So, I have to be very fast. I think this class is slow. So, charring, blacken. So that's one reaction they undergo. The other reaction, but this one is very specific to only monosaccharide, glucose in particular, is fermentation. Fermentation. There are some chains of reactions. I think you know what is polysaccharide. A carbohydrate with many blocks of glucoses. Many blocks of what? Glucose. Like now, if block, and you don't even know where the block will end. Once you see something like this, it's called what? Polysaccharide. Example, there are 3 in number. One is what? Another one is what? And one again is what? Glycogen. Glycogen is called animal fats. Animal starch, I mean to say. It's a form of starch in the animal. What do I call this bond that is holding to glucose again? What do I call that bond again? Glycosidic bond. Or the highly water affinity. Once what happened to the sugar? It splits. One will split into what? 2. Other one will split into 2. Split into 2. So which enzyme will split the starch or polysaccharide into 2? Because now I go into 2. When I go 2, the enzyme that split this thing into 2 is called what? Class diastase. They will ask you. Diastase. Then if this is glucose, then glucose cannot undergo hydrolysis because there's no bond to hydrolyze. Then glucose will now go into what? What? Ethanol plus what? CO2. Which enzyme catalyze the breakdown of glucose to ethanol? Who can tell me? Zymase. The reaction is non-spontaneous, so zymase, not only zymase, and also what? This is the condition for the reaction to proceed. I cannot come again. So I've told you that once you see chains of glucose, the chains are two pair. If the chains are broken into two pair, the enzyme that catalyzes polysaccharide into two pair is called what? Diastase. Then the enzyme that acts on the glucose is what? Zymase. There's another example called maltase. But you should know that maltase catalyzes maltose. Enzymes catalyzes the reaction substrates and add ACE to the substrates. Maltose is by maltase. Lactose is by lactase. But sucrose is not by sucrose. I think you know. Sucrose is by what? Invertase. Because it's an invert sugar. Okay, that is for that. Then, very important. Very important. Very, very important. Please, I will allow you to go and read protein. The only I think the only thing I'm going to say here this morning is that hydrolysis of protein, like polysaccharide, proteins are also complex. I think you know. Protein, another name is what? Protein, another name is polypeptide. Is what? Polypeptide. What is the building block of protein? The amino what? What is the end product of protein? The same question in different ways. It's the amino acid. The bond that holds two amino acids together is called dash. Peptide bond. Very correct. Just like you see this glucose, if this is amino acid, the bond that is holding two amino acids here is what? A peptide bond. Just like polysaccharide undergo hydrolysis, protein can also undergo hydrolysis. Hydrolysis of proteins gives you what? Amino acid. Hydrolysis of protein. And even if you want to test for protein, what you are testing is no other thing but what? The peptide bond. The best reagents to use to confirm presence of protein from a substrate is burette. There's other ones like xanthopretic is good, but xanthopretic can only distinguish tryptophan. That's aromatic protein to distinguish it from. So the best reagent to test for protein, in case they ask, is burette. Whereby if a substance is suspected to be a protein and you mix it with the burette and the color turns to purple, that substance is what? Protein. I think that is going to be the test they're going to, if to come out, that will be the test for protein. Of course, enough for glucose. I think I said glucose. Ferhelin. Ferhelin solution A and B. Ferhelin solution A is what? Copper 2. Unnatural blue. Ferhelin solution B is a complexing ion, which is sodium potassium tartarate. A complexing agent. Two of them can use because you need the copper nolofuma in a complex form in order to do what? Gain what? Electron. If copper gains electron, the only electron that will be donated to copper from glucose is only one because hydrogen has only one electron there. One. If copper 2 gains electron, what will it become? Copper 1. And what is the color of copper 1? Brick red or orange. Ocha orange, the man carbohydrate is not enough. Ocha brick red, the man the food contains what? Carbohydrate. In the previous SAY class, I think I've done that test with biscuits. Biscuit is glucose. You take sugar biscuit. Body tea test tube now. TFL in warm wine. If charred was brick red. I check a red and ready door. This door. That's for protein. That's the only question they will ask you. Hydrolysis of protein. The bond holding two amino acid. The functional group in protein are only two, just like carbohydrates. One is what? Carboxylic acid. And what? Amines. The two. Carboxylic acid and amines. That's the two functional groups in protein. And proteins are acidic. They're acidic because of the carboxy group, amino acid. Fat and oils. Fat and oils. The question they will ask you there is saponification. You should know saponification, your saponification reaction. You and saponification reaction should be 5 and 6. You should marry yourself together. You should know that saponification is what? Alkaline hydrolysis of what? Of alkanoids. What is alkanoids? Fat and what? Oils. I told you that fat and oils are alkanoids. I think I said it. But fatty acids are what? Carboxylic acid. Fatty acid plus propan 1, 2, 3 triol will give you what? Fat and oils. Plus water. Hydrolysis of fat and oil will give you what? What will it give you? Fatty acid and glycerol. Hydrolysis of it. Then when you have your fat and oils, vegetable oil like oil, I mean to oil. Is this saturated or unsaturated? Oil. Unsaturated. The process of making it hardened, solidified, in the presence of hydrogen, the process of hardening oil is called dash. Hydrogenation. Which catalyst is employed in hydrogenation? Nickel catalyst. Nickel catalyst. I should know the importance of oil. Oil is used in the making of soap. Soap needs oil. Just like you need water, soap needs oil like you need food. Without oil, no soap. Detergent does not need oil. That is why detergents are non-biodegradable. Detergent is what is responsible for what? Water getting pollution. No difference between detergent and soap. But I used to call the two of them detergents because detergent is something that can give a cleansing action. Soapy, soapless. But the examiners these days call one detergent, one what? Soap. Know the chemical formulas for soap. Know the chemical formulas for what? Detergent. Polymers. 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 Okay. Polymers. What are polymers? Polymers. Okay. They are giant molecules. You know what a molecule is? 18. Nene eba 18 is C. Nene about. Here 18. H, and what? H. This is 18. Condition for this 18 to polymerize is two things will make it polymerize. One is what? High temperature and what? Pressure. Oforofugemia 3. Catalysts. Ziglanata catalyst. When I am aboard now, Orumba, Acha on Dutcha Biega negotiate on Dutcha, my friend. I see you now. Ona one be talk, be not be say, you need multiply. If you know process to tack or Nige mezinambuzi, ona multiply is it? Now, one bond from this double will now be linking other ones that what? Multiplies. In a phenomena. If you get out to go, and it doesn't stop here, or continue, because I cannot be writing it continuously. I can just put bracket here, and put what here? N. N means that the chain still continue. Because this is many of these. I don't call this polythene. It is what? Polythene. It's polythene. Why is it polythene? Poly means many. So this is gotten from many of these. So it is the same ethene that was polymerizing to form what? Polythene. So polythene is a homopolymer polychloroethene. I'll take another one again, which is commonly known as what? PVC. Not permanent voters card. Polyvinyl chloride. It is also a what? Homopolymer. Homopolymer. Polypropene is a homopolymer. Helica. Polymethyl metaacrylates. PMMA. Perspex, you know now. Perspex. It's a homopolymer. Polyester. Polyamine. You know, polyamine is what? Is what? Nylon. That's what we nylon and simple nylon is. Nylon is a copolymer because the polymer from which nylon formed is named nylon sipota. Monomer nylon maburofie. Or for monomer nylon adipic acid, which is hexa-1,6 dioic acid, and hexa-1,6 diamine. They are the two monomers of nylon. Haburofie. If you look at that, the monomer of nylon, the monomer of nylon, hexa-1,6 dioic acid. There's one monomer of nylon. Another one is what? Hexa-1,2 what? Diamine. If I were examiner, I will go and waken this question up. The monomer of nylon. The monomer of nylon. Nylon is a copolymer. Homopolymer. If the monomers are what? Same kind. Do you know why polymer like polythene is non-biodegradable? Is this a biodegradable or non-biodegradable material? I think I came on a market. Do you know why among one? Do you see any double bond here? So it doesn't have any double or multiple bond that will be attacked by bacteria. So it is chemically inert, like alkanes. So since they are chemically inert, they cannot react with anything. That's even nylon now need to for organo. Yes. It will not degrade. The reason why it will not degrade is because it has what? Carbon what? Single bonds. Not only polythene, plastics. Plastic like PVC. Plastic like polypropylene. Fuse sockets. Plastics like urea methanol. These plastics are non-biodegradable. Why? Because because their polymers are what? Saturated. But their monomers are what? Unsaturated. The monomer of polyethylene, being 18, is saturated, but the polyethylene formed after is what? Saturated. Saturated means that it has carbon what? Single bond. So what am I trying to say here? Nylon 6,6. You know it is called nylon 6,6. Do you know why it is called nylon 6,6? Nylon 6,6. Let me show you something about nylon again. Now, if you look at this polyethylene, the process that forms this polyethylene, is it addition or condensation polymerization? Is it addition or addition? What makes it an addition polymerization? Who can tell me? What makes it an addition here? What makes it an addition process is because during the process of polymerization of the monomeric subunit, because we call it subunit, is there any loss of something when it is joining together? There's no loss. But if there's a loss of if there's a loss of small molecule like water, or small molecule like ammonia, or small molecule like hydrogen chloride, if any of these three escape when two monomers are joining together, what is it called? Condensation. You will see it in nylon now. So the process that forms nylon 6,6 is what? Condensation. It's not only it is a copolymer, but it is a type of what? Condensation polymerization. Nylon. Another name for nylon is polyamide. Take note. Poly what? Amide. Polyamide. It used to be called polyester before. Neighbor. 1, 2, 3, 4, 5, 6. Okay, who can help me with the name here? With the name here, who can tell me with the, this is what? This is what? This is what? What? How many carbon is it? How come here? 6. 6 is what? Hex. Okay. All the 6 are linked by single bonds. So what do I put here? And hexa. Sorry, hexa. Another one is coming. Hexa. 1. You go 1, 2, 3. This next one is what? 6. Hexa 1, 6. What? There are 2 dioic what? Acid plus. 1, 2, 3, 4, 5, 6. Okay. So what is this one? What is this one? This was the same as what? Hexa. Hexa 1, 6 what? Diamine. Now, you see, now see polyamines here. Water is gone. Water is bye-bye now. You see? So what is this thing going to look like now? 1, 2, 3, 4, 5, 6. When we watch now, this is like this. What's going to link to nitrogen up here? Nitrogen of this one. H. 1, 2, 3, 4, 5, 6. Okay, that's it. That is it. So what is this? What is this long? What is this long chain now? What is this in? This is called what? This is called what? Nylon. Why is it called nylon 6,6? Nenia, it's about gonya. Can you say N H H H? Okay. Then you have 1, 2, 3, 4, 5, 6. The carbon to which this N is linked is 6. 1, 2, 3, 4, 5, 6. The carbon to which this is what? Is liquid? Is 6. So the linkage is done in what? Alpha 6, 6. So it's called what? Nylon, what? 6,6. But here about alpha, nickname. But the proper name is what? Nylon. So nylon now, the reaction, any condensational polymerizations, they often are reversible. Any reaction in which something forms by loss of water can what? Can be reversed. So hydrolysis of nylon 6,6 will give you dash and dash. Hexa 1,6 diamine and hexa 1,6 dioic acid. Take notes. You have to know the monomer of nylon, monomer of ethene. Okay, nylon is a copolymer, ethene is what? Homopolymer. Take notes. Take notes. The process of starch formation, for formation of starch, will you say that starch is condensation polymerization or addition polymerization? Starch formation, is it polymerization? Is it condensation or addition? It should be condensation. In the case of starch, starch is from C6H12O6. Now listen to me. When many numbers of water molecule is gone from this sugar, what are we going to have here? H10O5 bracket what? You know, I told you, anytime you are drawing a structure of a polymer, always make sure there is what? N. Always make sure there is what? N. This is a polymer. So for the fact that there is a small molecule that is removed from this particular monomer, the polymer form is what? Condensation. So starch is condensation. Starch is condensation polymerization. Protein, which is formed by repeating unit of amino acid, is protein condensation polymerization or addition. Protein addition or condensation. Protein is also what? Condensation. When two amino acids are joined from one carboxyl end and one amine end, the water molecule must be what? Eliminated. Water molecule must be eliminated. So any monomer joined by elimination of water, the polymerization is condensation. Please take notes. It is condensation. Finally, I want to discuss on a very important aspect of polymer, which is a polymer that has to do with if we want to classify polymer or polymerization in terms of source. In terms of what? Sources. We can classify polymer into two. As what? One, we have what? Natural and what? Artificial. Natural and what? Artificial. What are natural polymers? Those ones from plant and what? Animal what? Origin. A typical example of such polymer is what? Latex or natural rubber. Latex or natural rubber. I want to classify polymer now in terms of source. In terms of what? Source. I will have two types, which is what? Natural and what? Synthetic or artificial. Then on natural, we have what? Latex. Latex is a natural polymer. Naturally, it is called latex, but the chemical name is called what? Polyisoprene. Poly what? Isoprene. It's very important you take that. It's very, very important. You take notes. Polyisoprene. Now look at it. So here is my word, natural rubber. Here is the monomer. So let me start with what? Latex. Latex, in bracket what? Natural what? Rubber. Or what? Poly what? Isoprene. Polyisoprene is normally, it is what? Look at the structure here. 1, 2, 3, 4. CH what? 3. Bond here, H, 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 H. So this is the so-called polyisoprenes. Someone should help me name the compound. Name the so-called polyisoprene. 2-methyl up here. It's 2-methyl. Now can't you see? 1, 2, 1, 2, 3, 4 is buta up here. Buta. Do you know why I'm putting A there? Buta means there are multiple bonds all through in position what? 1 and 3. Then diene. That is it. If I put poly in front as a prefix, it means that it is many. And in natural rubber or latex, there are many, I repeat, many isoprene units. Many words, isoprene word units. So what will I now write here as the monomer of latex? The monomer of latex is what? Is what class? Isoprene. Is what? Iso what? Prene. Isoprene. Or what? Or what? 2 what? Methyl what? Buta what? 1, 3 what? Diene. Take notes. Naturally, this natural latex or rubber is a white viscous liquid. It's a white viscous liquid, very soft and sticky. I repeat, very what? Soft and what? Sticky. Then, one or another somewhere now look at this very white, soft and sticky white fluid and decided that something can be done. Something can be done, and that white fluid that is soft can become useful to black people like us. They decided to go and heat that white liquid. Add one particular non-metal to it. What is that non-metal they added to it before heating? Sulfur. They heat that liquid with sulfur, and then upon heating the liquid with sulfur, the liquid hardened. Not only hardened, the tensile strength increased. And then the white man decided that he can use it to make your sole of shoe. And then even make some plastics and even tire, Michelin tire. The process of heating this white liquid called latex with sulfur until it hardened is called dash vulcanization. Not just vulcanization, we call it what? Vulcanization of what? Rubber. Are you aware that vulcanization of rubber, is it artificial? Is it synthetic or natural? Synthetic. Vulcanized rubber is synthetic. You can vulcanize a natural rubber, it becomes synthetic. But if you are not, if you don't vulcanize it, it is still what? A natural rubber. The one that it came from plants, you extract it, and then you go and heat it with sulfur. What is the role of sulfur? What role does sulfur play in that process? It binds the what? It binds parallel the monomers. It binds the monomeric unit parallel by forming a what? A cross-word link between the monomers. It forms that cross-link by bringing the monomers together. In the process, it hardened the rubber. That hardening of that rubber by that sulfur is what today we refer to as what? Vulcanization. The element used in the process is sulfur. Sulfur is good in the sense that sulfur is solid and sulfur can give 2 electrons needed for that binding. Okay, man, sulfur has how many lone pairs of electron? How many lone pairs of electron? 2, like oxygen. They use it because of it has 2 lone pairs. It can bind one up and bind one what? Down. It can't use oxygen because it's gaseous. So if they ask you the choice of sulfur, you say because it's solid, and also it can also offer 2 lone pairs of what? Electrons for binding the 2 monomers. And if you bind the 2 monomers, there's nothing you cannot use that latex to do. You can use it to make some items like tire. Even though we have other rubbers, like one made from the beginning, artificial. I think you know the ones that are artificial. Artificial rubber, what is the monomer of artificial rubber? The monomer of artificial rubber is what? Neo what? Neoprene. This one is from beginning till end. It is what? Artificial. It is what? Man-made. How is it man-made? The same undocha. There we go. And again, again. Neoprene. Polyneoprene is the polymer. Are you aware? Neoprene is the monomer. Polyneoprene is the polymer. Is polyneoprene a copolymer or homopolymer? Before you know whether it is homopolymer or polymer, you must know the monomers of what? Because not knowing neoprene is just like a common name. The chemical name is what? We have what? Polystyrene. There is what? There is styrene there. There's what? Styrene. And there is what? 2-chloro-buta-1,3 what? Diene. The two together. That's why the main artificial rubber is SBR. It's called styrene butadiene rubber. The main natural rubber. And you watch, if the one that the trees can offer us, the natural one cannot be enough to go around. That is why a means of what? Getting these rubbers from other sources. I think we have more synthetic rubbers than natural rubber. We have more synthetic than natural rubber. Even with that synthetic rubber self, they still undergo vulcanization. Vulcanization is a process to make that rubber tend to what? To have high resistivity, to have high pressure. So even if it is used to make sole of shoe or tire, it can resist all kind of what? Pressure. That is the essence of what? Binding it more. Using what? Sulfur. There are other natural polymers. We've not mentioned natural polymers like protein. Protein is a natural polymer. Proteins. What is the monomer of proteins? We've mentioned it several times today. Is what? Amino what? Acid. Protein is polymer. Its monomer is what? It is also starch is also what? A polymer. It's a natural polymer. It is from plants. Amino acid too is also from where? Plant. I think I said they are from either plant or what? Animal origin. Then these are plant, and plants. At what point does plants make starch? I think plants, you know what is photosynthesis? You know, glucose is very, very unstable. As soon as plants makes glucose, they store it as what? Starch. Because it's unstable. Hydrolysis of starch will give you glucose. So the monomer of starch is what? Glucose. Other polymers are what? Glycogen is also what? Glucose. And so on. We wouldn't want to put fat and oils as a polymer. It is not actually a polymer. Fat and oil falls on the categories of giant molecules, but it's not qualified as a polymer. Just like your so-called diamond and silica gel. Silica gel too is also a giant molecule, but never a polymer. So these are the things you need to get yourself acquainted, to know all these things. And time will not permit me all these polymers and their uses. most especially those polymers like perspex. Are you aware that perspex is to replace glass in the next few years? This glass now, the next few years, perspex is going to replace them because they are as transparent as glass. Perspex, we can use here now. It will bounce. It's transparent as glass. It's a rubber, but all the highly transparent. They say each of the polymers that have high transparent, just as glass. The answer is what? Perspex or PMMA. I think you remember the thing here as polymethyl metaacrylate. This is what they go. PMM, polymethyl metaacrylate. Again, not cheap glass very soon. The reason is because it's what? It's transparent. Which polymer is used in the manufacture of crates? Crate mania, crate beer. Crate beer. Crate beer. Rope. Kema odo. Odaja wefi. K polymer jar, those things. You can use polypropylene for making crates. You can use polyethylene for making crates. But you can only use polypropylene to make rope. You should know this. So it will not be a case whereby you read every of those simple questions that will throw you off balance. You don't let it to be a portion. It will not be a portion. So tidy all these things. Like I said, the exam will not be difficult. Okay. No. Time is not on my side. Please, my assignment is to go and read all the polymers I've mentioned so far. Even though that ones you know. Like urea methanol. These things you see here are made from urea methanol. This plug switch. This. I keep my plug with the sockets. Here that's 2 or 3 plugs. That is urea methanol. So go and read the functions of all these polymers one by one. In fact, find out something to use to memorize these uses so you don't relate it to the other one. Like nylon, of course, you know most fabrics are made of what? Nylon. Nylon is not polyethylene bag. Nylon is not what? Polyethylene bag. There are 2 polymers that you can use to make polyethylene bag. One is PVC. 2 is what? Polyethylene. These are 2 polymers that can be used to make plastic or polyethylene bag, not nylon. Nylon is for fabrics. Okay. Finally, in terms of heat, always some polymers, heat they melt. There are some polymers, heat they will not melt. So those polymers that soften, that are being softened by heat, and there are some that are not softened by what? Heat. Based on effect of heat on polymers, polymers can be divided into 2. As number 1 is what? Thermoplastic polymer. Please, there, Keta. Based on effects on heat, polymers can be classified into number 1, thermoplastic polymer, and number 2, thermosatin polymer. Thermoplastic polymer, and number 2, thermosatin polymer. Thermoplastic polymer, thermosatin, thermosets, like this. Thermosatin polymer. Okay. Now, thermoplastic. Thermo means heat. Thermosetting means once the plastic is set, there's what we call set. Every process of making plastics will always go under high pressure, high temperature. You see at a point, this plastic seat you are sitting on, they are once like pure water during the process of manufacture. And then when they are cooled, what happens? They set like this, Abby. Yes, that is on cooling. They become set. But there are some plastic or polymers that once they are set, if you hit those polymers, they will not soften again. And you cannot recycle those polymers. Ndane pick a plastic if we are hane will you to fuel because we will log about. Ndana to you for plastic it to they will see it that they have won lottery because this seat now is a plastic that heat can what? Smelt or soften. And then if you notice that if it can be softened by heat, it can be recycled over and over again. So any plastic that it can be softened by heat and recycled several times is called what? Thermoplastic polymer. I repeat, any plastic that can be softened by heat, sorry, I don't know that I have boundary. Any plastic that can be softened by heat and then recycled several times. Not only that, it is being softened by heat and can be recycled several times. It's called what? Thermoplastic polymer. Thermo what? Plastic polymer. Any polymer that if heat descend on them, if I have a polymer, if you have a polymer and it is what? And it is what? Soften. And it is soften. You see now? Softens. And again, cooled. Are you there? And again, cooled. And then go back to the polymer again. What do you call that polymer? Thermoplastic. Okay. It's called what? Thermoplastic. Examples. Examples, knowing example is very important than even knowing because it's very simple. Just know that thermoplastics are softened by it. Thermosetting, once they are set, they are not softened again. Example of thermoplastic, I think you should know polyethylene. Polyethylene, polypropylene, polyvinyl chloride, PVC, polystyrene, nylon, polyesters, polymethylmethacrylates, perspex. Polymethylmethacrylate, PMMA or perspex. PMMA or perspex. In fact, majority of additional polymers, in fact, all additional polymers are what? Thermoplastics. Except what? Nylon 66. Except nylon 66. Because nylon 66 is what? Condensation. Except nylon 66. But all other ones are what? Are what? Thermoplastics. Then what is thermosetting polymer? Thermosettings are those polymers that once they are set, once they have gone into the process of now being set, once they are set, once they are solid, once they are set, they cannot be softened again by what? Heat. So that means you cannot recycle them. They are thermosetting. Example, all condensation, some artificial, because anyway, natural condensation polymers and artificial condensation polymers. So you know, so all artificial condensation polymers are what? Thermosets. Example, urea methanol. Urea what? Methanol. Urea methanol. Epoxide resin. urea methanol, epoxide resin. There's one that I'm thinking, bakelite, correct. Bakelite. Bakelite, do you classify bakelite as copolymer or homopolymer? Bakelite. Bakelite is copolymer. Bakelite is the what? Copolymer. All the things you see here are copolymers. Urea, formula urea is different from methanol. Epoxide, the same thing. All, and they are all process of condensation. Before they are joined, there must be a loss of what? Water molecule. Water molecule. Again, I urge you, please, their functions, their uses, their usage is more important. More what? Important. Important, more important, because they are testing your skill. Some examiners' interest will be that skill. Whether you know, if you see this thing, what is it used for? So please, I urge you, all the polymers I've mentioned because of time, go and read and know their functions. In my next session, or my next class, if there'll be time, I will also give you the functions of the most important ones. Okay? If you have any question, you can ask me now because of time. Because you have to go for a break and another session of organic chemistry is still coming. If you have any question, you can ask me. I just have 5 minutes, 5 minutes, just 5 minutes. Okay?
So, after fermentation, ethanol and CO2, how can you separate it?
Okay, say after fermentation, how can you separate it? You don't separate them because already they can separate by themselves. No, normally your fresh palm wine, your morning tap for palm wine is highly sweet in the morning, right? Because the sugar is not totally fermented. The moment you tap freshly palm wine, the yeast there starts to what? To ferment, to break down the sugar. Where it breaks down the sugar until all the sugars are converted to what? To that ethanol. And the process, you now see, most time you see palm wine poured inside a cup, you start seeing some bubbles going off. You start seeing some bubbles, isn't it? That bubble is the CO2. They are evolving. Therefore, they are escaping through the what? Atmosphere. That's why you don't cork the bottle. If you cork the bottle, it will shatter. That is the right word to use. It will what? Shatter. Even the local palm wine tapper, they know they will not close their bottle, their palm wine bottle, their keg of palm wine. What do they use there? They put what? To make sure that they prevent flies from going in. They cannot close it with the what? Stopper. Because the accumulation of the gas will what? Will shatter the bottle. The gas will accumulate there. So the gas will easily what? Escape. Where there will be a problem is if the CO2 is a liquid alongside ethanol. That's where you now talk of what? Separation techniques. There are other things that are in the alcohol that you separate. Like there is methanol. Methanol is that content in the alcohol that is intoxicating, that is very toxic. So process of removing that methanol by boiling that palm wine is called what? Fractional what? Distillation. So you can still distill it. But if this is the original shebe, okay, kai. You remove water. So the if you wasting that mixture, can absolute alcohol. And can water and can brain I like here. I will tell you much the reason why yes. Brain, okay for brain. You want your week just your brain, check oil. Yes, other question.
In the hydrolysis of starch, what is dextrin?
Good question. Say in the hydrolysis of starch, what is dextrin? Dextrin has been a name for dextrose. Dextrose sugar is sugar that it is a form of isomeric sugar Like we have lavo sugar, dextrose sugar. Okay? Dextrose sugar, they are sugar that can rotate a plane polarization. They are sugar that are in D form, like you have D-glucose. So that dextrin there is dextrose. Are there? That dextrin there is glucose, or simple word, sugar. At what point in that hydrolysis of starch, if you hydrolyze starch, the first thing you will get from starch is pair. That is diastase. Then the next thing again, you will see if you dissolve the pair. Any pair like this you dissolve, you use maltase to dissolve it. Then when you get to a point where you only have a single sugar, it is that point you can now use the word what? Dextrin. Or you can even use dextrin from the beginning, because these are many dextrins in starch. So dextrin is what? Is D-glucose, or dextrose what? Sugar. It's just like a configuration or conformation of what? Sugar. Sugar is conformed that it has D form, or sugar is conformed that it has what? L form. So majority of sugars are in D form. They are called what? Dextrose or dextrin. Yes, yes. Next question, please. Okay. Okay, on the board there, see, which of the following is a thermoplastic polymer? Bakelite, melamine, polyethylene, urea formaldehyde. Urea formaldehyde is something of urea methanol. Are you aware? Methanol is something as formalin or formaldehyde. So which one there is thermoplastic? Polyethylene. I think you know why polyethylene is thermoplastic there. It can soften by heat and can be removed several times. Number 2. The natural rubber is a polymer of what? Is it isoprene? It's very correct. But if it is artificial rubber, what then will it be? But what if you're not seeing these old names on the in the options? What are you going to see now? In the place of isoprene, what are you going to see there? 2-methyl-butanol-1,3-diene. Thank you. Which of the following is used to make bulletproof glass? Okay, if you check that this thing, I think that's a catch-up. I think I gave you that all carbonate compounds are used in making glass. All carbonate compounds are used in making glass. So which one is used in making bulletproof glass? You know, if you want it to be bulletproof, you don't need the glass to be very high density glass. So the high density glass is the number of what bicarbonate you use in making glass. So any glass are made from where? Carbonate compound. A typical example is what? Sodium carbonate. But if you want the glass to be colored like this blue glass here, what will you add to it? Cobalt, Abi? Cobalt oxide. This is blue. It goes to give the glass blue. Or any color you desire. If you want your glass to be pinkish in color, you add manganate to what? Oxide, as the case may be. Bakelite is an example of dash. Is it thermosetting, elastomer, fiber, or thermoplastic? Thermosetting. Which of the following is not synthetic? Among them, nylon, Teflon, silk, PVC. Silk it is. Silk is cotton. Silk is from cellulose, or it's from cellulose acetate. That's the chemical name for silk. Cellulose what? Acetate. So the only one there that is not synthetic there is what? Silk. Teflon is a polymer from polytetrafluorethane. That is Teflon. Someone like me can even manufacture that one. So it is what? Artificial. Next one. PVC stands for dash. Oh, when you guys know polyvinyl compound, it is what? Polyvinyl chloride. If I were to be the examiner, one of my options will be permanent voter's card. And you know that there's some cocoa here that will go for that option. Which polymer? Hey, I'm supposed to mention this one. That's why I say you should go read the function of polymers. Those ones I mentioned. Which one is, okay, you know what is non-sticky frying pan? Yes. Is non-sticky pan. I think it's how do you call it? This one is non-sticky frying pan. See, which Which polymer is known as non-sticky that have non-sticky property? Some of them are used in making frying pan for frying egg. The moment you are frying, even if you don't have oil to fry, that egg will not stick on the pan. Which one? Nylon, PVC, Teflon, and polyester. Nika said it is a distinguished answer. Imago na mambo nylon. Nylon is for fabrics. Imago na mambo PVC. PVC is for plastic and bags. Imago na mambo polyester. Polyester ne nyelo kwa nylon aka in the fabrics. Okay, what I make it? Imago no gabogene Teflon. Just questions you see that you're not to do elimination what method on them. The monomer of polythene is that. Polythene is what? You know they will not give you ethylene again. It is what? Ethylene. Ethylene. Next question. The polymer used in making ropes. I think I told you. Yes. Now you know I didn't mention all of them. I told you. I think I gave you polypropylene can be used to make rope. Even polythene can be used to make rope. But I didn't mention the next one, which is what? Ash. Sulfur. I say we can ask which element is used in the vulcanization of rubber. Which non-metal is used in the vulcanization of rubber? Answer is what? Sulfur. Polyester is commonly used as Teflon coating, fibers and textile, pipes, electrical installation. Which one is correct? Which one is used as fittings? Electrical installation of fittings. I think you're supposed to sit in this question. You're supposed to come here. I think I told you anytime you hear something about electrical fittings, you can use something like methanol. Those ones that if we or melt to godi or man will mill it to not soften by heat. It can be deformed but not softened by heat. Okay. So you use please go back, sir. Please. You use for go back and the former question. I want to say something there. Polyesters commonly used in have similar uses like PVC and thermostatin. Now, in fiber, in cellulose acetate, there is a cross wall between the monomers. That is why in cotton or cellulose is a polysaccharide alongside starch. But the difference between cellulose and starch is that cellulose is non-digestible. The body cannot digest it. But starch, the bond. Please go to the next question. The example of natural rubber is what? Please be fast. Natural here is what? Cellulose. Cellulose acetate. Go for it. Next question. Which of the following is a copolymer? Copolymer. Nylon what? 6-6. Very correct. Which thermoplastic can be recycled? Check other one, molded ones. No. So the answer is what? Recycled. Next question. What is the repeating unit of polystyrene? Polystyrene. Do you know what is polystyrene? Polystyrene is phenylethene. Oh, go at it. It's what? Phenyl what? It's a phenyl. Phenyl is benzenyl or benzene derivative, just like a methyl and methane. Just like methyl is to methane, phenyl is to benzene, or benzene is to phenyl. So polyphenyl or phenylpolene, I don't know, is what? Is polystyrene. Oh, if it is mini, it's called polystyrene, like this. That is polystyrene. Many of this polystyrene. Put bond here. So the repeating, please come back. Let's just. The repeating unit of polystyrene. Neni akole kiri na body ban. Kiasi gabaya. Neni 6 1 2 3 4 5 6 6 H5 1 2 3 4 5. Imagine H eba. Then a bond is to gain CH akuya and CH. Have a mistake eba because it's to eba. Okay, so CH and CH with what? Double what? Bond. So the answer is what? B. Next question. The process of making polymer is called what? Next question. Which of the following polymer is used in packaging? If you want to package, use low density. High density. High density polythene. Bundi use high molecules of a team women. See, cheap package, Karama de Gote, now. Use those of what? Of low, high density bundle, pipes, all these thick pipes. So if you want packaging, use low density. If you want high density, the one that can carry water from one toilet to the what? Latrine. Use what? High density polyethylene. So the correct answer is what? LDP what? E. High density what? Polyethylene. Please write the full meaning here. No, sorry. For packaging, use low density polyethylene. For PVC, for piping, what will you use? High density what? Polyethylene. The polymer used, next question 23. The polymer used in making plastic bottles is here PVC, PET, nylon, Teflon. This question is confusing somehow because you can still use PVC to make plastic bottle. You can still use PET to make plastic bottle. That is polyethylene tetra or polyethylene, what do you call it? This is polyethylene. You can use PVC for plastic crate. You can use PET for plastic crate. So P, A, and B here should be very what? Correct. So far is plastic, what do you call it? Plastic what? Plastic bottle. Or crates. You can use either polypropylene, polyethylene, or what? Polychloroethylene. Next question. Polymers used in synthetic fibers is what? Nylon. Which polymer is known for high impact resistance? The same thing, polycarbonates. Polycarbonates, those ones used in making glass. Next one. Next one. Which polymer is commonly used as synthetic substitute for silk? You can use polyester. You can change polyester. We go back. Go back, okay. You can use, which polymer is high resistant of chemical? You have changed it. The polymer used in high resistance for chemical is okay, now let me tell you something. I think I told you something about high resistance to chemical. Any polymer that has just single bond between the two monomers are non-biodegradable. That means they are resistant to attack. Whenever you talk about a polymer being resistant to chemical attack, you concentrate more on those that are artificial rather than those that are what? Natural. Because the one among this here is what? Is Teflon. That is polytetrafluoroethylene. Next question. 28 and 29. It says it's going to be how many questions? Which of the following has this? I think I mentioned it as Teflon. 30. Which of this is a linear polymer? Linear polymer. Linear. Have you seen the structure of nylon? How is it? I think you see the compound nearly finished this border here. So that is the one that is linear. If you have seen bakelite is a urea. Urea is triangular in shape. Then methanol is straight. So that one is not straight. Same thing with LDPE. The same thing with what? Melamine. The only one that is a linear polymer, straight polymer, is what? Nylon 66. I think with this, we have to what? Call it what? A day. At this juncture, thank you for listening. Thank you, Chief.
Celebrate Dr. P now.